Okay, class. So on today's agenda, we're going to continue with more aspects and parts of triangles. On today's agenda, we're going to talk about the largest angle equals the largest side rule for triangles. We're also going to discuss the smallest angle is equal to the shortest side rule for triangles. And then we're going to get into the triangle inequality rule. After we've reviewed these rules, we're going to start working on page 298, numbers 6 through 11, on page 299, questions 14 through 19, and then 24 and 25, page 305, questions 7 through 15, and then we're going to do a couple of more exercises on page 73, 1 through 12, and page 75, 1 through 13. So let's start with the largest angle equals the largest side rule for triangles. If you notice here, I have a triangle. I've labeled the angles 1, 2, and 3, and I've labeled the sides of the triangle A, B, and C. The largest angle equals the largest side rule just simply states that the biggest angle is across from the biggest side. So if I look at my angles 1, 2, and 3, I hope you can realize that angle 2 is the biggest angle. And if I come out of angle 2, you will notice that angle 2 is pointing at side C, meaning that since angle 2 is the largest angle of the triangle, side C is the largest side of the triangle. Similarly, we have the smallest angle equals the shortest side rule for triangles. And what that's saying is that the smallest angle is across from the shortest side. So if I look here at this triangle, I have sides A, B, and C. I have angles 1, 2, and 3. And if you notice here, A is the shortest side, which means then that angle 3 is the smallest angle. So if you look here, angle 3 is the smallest angle, and it's pointing towards A, the smallest side. Let's take a look at an example. Here, I have triangle ABC, and I've marked off particular angles. This is 48 degrees, 58 degrees, and 74 degrees. And a question like this would probably ask you, name the sides of the triangle from smallest to greatest. So let's look for the smallest side. Well, my sides don't have any numbers, but my angles do. So I would look for the smallest angle. If you notice here, 48 is the smallest angle. And the side that is across from 48 is side B. So that means that side B is the smallest angle. Then I look for the next biggest size, which is 58 degrees. And 58 degrees is across from side C. So I know that side C, since 58 is the medium side angle, then side C is the medium sized side. And then finally, I have the biggest angle, which is angle 74, and it's across from side A. Since 74 is the biggest angle, that means that side A would be the biggest side. So here I have, in order from smallest to greatest, I have side B, side C, and the largest is side A. Please remember, guys, that this symbol right here means less than. It's like a L that's been squished. And this symbol here means more than. And one of the possible ways that you would see your response for this would be then that angle B is less than angle C, and angle C is less than angle A. And that's one way that they might decide to put them in order from least to greatest. Or they could also say that angle A is more than C, I'm sorry, not angle A, side A, I'm sorry, side A is greater than side C, and side C is greater than side B. Let's take a look at another example. Here I have another triangle, and this time I've labeled the sides. This side here is 65 feet, this side here is 25 feet, this side here is 45 feet. And a question like this would probably ask you to name the angles from smallest to greatest. Well, none of the angles have numbers, so I can look to the sides. Which is the smallest side? Well, this angle right here, this side right here is 25 feet, is the smallest side. And I know that the smallest side, according to the rule, is across from the smallest angle. So if 25 is the smallest side, then angle 1 is the smallest angle. Angle 1. Then I look for the next biggest side, which is 45. And 45 is across from angle 3, which means that angle 3 is the next biggest angle. And then finally, I'm left with the biggest side, which is 65 feet. And 65 is across from angle 2. So angle 2 would be the largest angle. And again, going from smaller to greatest, I can say that angle 1 is less than angle 3, which is less than angle 2. And those are the rules of the largest angle equals the largest side rule, and the smallest angle equals the shortest side rule for triangles. Now, let's talk about the inequality rule. The triangle inequality rule states that the sum of the lengths of any two sides of a triangle is bigger than the length of the third side. The sum of the lengths of any two sides of a triangle is bigger than the length of the third side. So what does that mean in plain English? Well, what that means is that if I take side AB plus side BC, both of those together are going to be greater than side AC. And I put that here as an inequality. AB plus BC is going to be greater than side AC. And I think we can all agree on that. If I added these two sides here together, they would be bigger than this side here. Also, side AC plus BC is going to be bigger than just AB. And I have that here. And finally, side AB plus side AC, these two sides here, is going to be greater than just side BC here. And I think we can all agree upon that. But it's very important to know that any two sides added together are going to be greater than the last third side. Let's take a look at some examples. In this question here, they ask us to solve the inequality of AB plus AC is greater than BC. Here I have my triangle ABC. Side AB is x plus 2. Side AC is x plus 3. And side BC is 3x minus 2. Let's solve this inequality. Well, AB is x plus 2 plus AC is x plus 3. And we're saying that that's greater than BC, which is 3x minus 2. And all we're going to do here now is that we're going to combine like terms. So let's do that. Let's combine like terms. X and x comes out to be 2x, and positive 2 and positive 3 is positive 5, and that's greater than 3x minus 2. And what we have here is an algebraic equation where instead of having an equal sign here, what we have is an inequality sign. This is a greater than sign. So let's do a little algebra here. Let's say I have negative 5 minus 5. I'm going to get 2x, cancels out, is greater than 3x minus 5, minus 7, that's 7. Okay, and now I'm going to subtract negative 3x from both sides. And that is going to give me negative 1x is greater than negative 7. And I'm going to divide both sides by negative 1. And if you remember from Algebra 1, there's a rule that says that if you divide both sides by a negative number, or if you multiply both sides by a negative number, what happens to this inequality sign? If you guess that it flips, you guess correctly. Because I'm dividing both sides by a negative sign, this is going to change directions. So I'm going to have x. This is going to switch sides, and negative 7 divided by negative 1 is positive 7. So x has to be less than 7. What that's saying then is that this inequality, for this statement to be true, in order for this statement to be true, the variable of x has to be less than 7. Let's take a look at a harder example or a harder question. Let's say here that they ask us to find the possible measures for segment xy in triangle xyz if xz is equal to 6 and yz is equal to 6. Well, if you notice, the first thing that they didn't do is they didn't give me a triangle. So what I'm going to do is I'm going to draw my own triangle. And I know that I have the letters x, z, and y, so I'm going to label them x, y, z. Doesn't have to be in any particular order. I know that xz is 6, so this is going to be 6. I know that yz is also 6. This is also 6. And they want us to find the possible measures of what? Of xy. Well, according to the inequality rule, I know that if I add yz and zx together, they have to be greater than what? These two sides together have to be greater than which side? If you guessed xy, then you're correct. So my inequality would look like this. Yz, here's segment yz, plus segment zx has to be greater than just xy. Well, let's take a look here. I know that yz is 6 plus, and I know that zx is also 6. So I know that those two together have to be greater than xy. When I add them together, I'm going to get 12 is greater than xy. Now, this is my answer. Now, it's a little bit hard to read. If you remember in Algebra 1, they told you that when you have an inequality, it's always good to have the variable on the left-hand side so that you can read it a little bit better. So I'm going to put my xy here. I'm going to put my 12 there so that I can read the variable first. And since I switched these, I'm also going to switch this here. Now what this says is that xy has to be what? Smaller than 12. So it can be 11, it can be 10, 9, 8, all the way down to 0. Now could it be negative? Can you have a negative side? The answer is no. So xy is less than 12. So it's anywhere from 12 all the way down to 0. And those are your possible values for xy. Now that we